Hi, this is Mr. Klein, and I'm going to do one more example of how we look for patterns to solve problems. It's going to be example number 3 in your packet, Comerica Park. If you don't have your packet out, pause the video and take it out, and then press play again. Okay, here we go. So the broadcasting team for the Detroit Tigers joke about the number of fans that don't stay for the whole game. Imagine that on one particular summer day, 100 fans get up and leave after the first out of the first inning. After the second out, 150 people get up and leave. The pattern continues, where after each out, 50 more people get up and leave than after the previous out. So after the next out, it would be 200, and then 250, and then 300. Assume that there are 6 outs in an inning because both teams get 3 outs. We have 2 questions to answer today, and here's the first one. How many people get up and leave right after the 7th inning stretch, which happens halfway through the 7th inning? Let's begin with that question. So, a good way to begin is to gather some inputs and some outputs. Where we have the first out, the second out, the third out, the 4th out, the 5th out, the 6th out, and so on. By the way, those 6 outs would encompass inning number 1. And over here, we're going to chart the number of people that leave after each one of these outs. So it would be 100 for the first, 150 for the second, 200, 250, 300, 350. Next thing we need to figure out is what out are we looking for? So the 7th inning stretch happens halfway through the 7th inning, which means we have completed 6 innings. So we've had 6 outs times 6 innings for a total of 36, plus half of the 7th inning has happened, so we've got 3 more outs for a total of 39. So what we want to figure out here is what happens after the 39th out. One approach, an approach I want you to avoid, would be to just continue this list until we got to the 39th out. The one that I want you to do is I want you to look for a pattern. So for instance, I want you to notice that this right here is really 100 plus 50. And that this is 100 plus 2 times 50. That 250 is 100 plus 3 times 50. 100 plus 4 times 50. 100 plus 5 times 50. Ooh, and if I wanted to, I could call this 1 times 50. Now the reason this is helpful is that if you look at the number of outs that have happened and the number in our pattern here, 3 and 2, 4 and 3, 5 and 4, 6 and 5, what you can see is that this number right here is always 1 smaller than the number of outs. So if we wanted to know the number that leave by the 7th inning stretch, what we could do is say that it's equal to 100 plus, since it's the 39th out, and this number is always 1 smaller, we could do 38 times 50. And if we get that, we find that 2,000 people left at that time. So that's part 1 of the problem. Here's part 2. We're asked, how many people leave before the game is over, assuming that it lasts all 9 innings? Well, if it lasts all 9 innings, that means that there are going to be 9 times 6 equals 54 outs. And then let's work backwards a little bit. 53, 52, 51, 50, 49, and so on. You can fill in the space in the middle. The last out, we know how many people are going to be leaving at that moment. It's going to be 100 plus 53 times 50. And if we work that out, that gives us 2750. And then I'm just going to add a few going backwards. So this would be 2700 because it was 50 fewer, and then 2650, 2600, and so on. And now we notice a secondary pattern, which is this. If you look at the first out and the last out, and you put them together, that's 100 plus 2750, that's 2850. Now if you look at the second out and the second to last out, that's 150 and 2700. Hey, if you put those together, you get 2850. Now if you take the third to last out, or third out and the third to last out, and you put those together, 200 and 2650 gives us 2850. So we've got pairs, and each pair equals 2850. We also know the number of pairs that we have. We start at 1, we end at 54, so the number of pairs equals 54 divided by 2, which is 27. So if we have 27 pairs and each one of them is 2850, the number that will leave is going to be equal to 2850 times 27, which gives us 76,950 people, which incidentally is more than Comerica Park holds. Oh, but there's a catch. Here's the catch. The problem says how many people leave before the game is over. And technically, these people right here, they left after the game is over because the last out had happened. So the answer is actually going to be equal to 76,950 minus those last 2,750 people, which gives us a final answer of 74,200. So that's an example. The two kinds of thinking that we did here, the first where you needed to generate the pattern and then figure out the rule, you're going to see that in today's problems. And the second where you had to look at the pattern and combine pairs in order to get a sum. You're also going to see that in today's lesson. So now I want you to get started on the problem set, and you should finish through the last problem today.